In our last video, we saw how to graph a system of linear inequalities. We'd graph the two regions and we'd see where they'd overlap. Well, we're going to turn this now into some applications with the same idea, just some short story problems here. There's not a ton of this section. So what we're going to do is we need to make two different equations. So she's got, let's see, she's got small photos and she's got large. So I'm going to make my dictionary over here. So small photos and large photos. Now we need to make two equations out of this, and so maybe I should say the number of small photos, the number of large. So she's going to add these up. So if I had the total number, she wants to have at least 25 photos to display at her booth. So at least means that I'd be happy with 25 or more. So I want an equal sign, but I'd be happier if I were at least 25, so greater than or equal to. Now that's one. Now let's make a second. If each of her small photos cost $4 to display and her large photos cost 10. So do you see what I've done here? So we've seen this idea before. We're just multiplying the cost times how many we have, like we did with the coins. We've done this many times. So $4 for the small, it's $10 per large. So this is now a total amount of money. Now, she doesn't want to spend more than 200. Well, that's the total amount of money. So no more than 200 would be less than or equal to 200. Okay, now let me see how they've done. That's all that we've done here. Now, they've graphed these, and so they both had equal signs in them. So now I would have graphed them like this. I would have turned these into these equations. Or y, so I'm just solving them in the slope-intercept form so I could graph these easily. And then here, I would do the same with the bottom one. I'd have 10y was less than or equal to negative 4x plus 200. I would divide both sides. You'd have to do this entire side. So I'm jumping ahead here, but I've given the 10 there and reduced it. I've given the 10 there. You got to share the 10 into both of them if you're going to do this. So we've done that before as well. Okay, so you'd graph both of these lines as if they were equal signs. And now they're both filled in. Now the reason I do it this way is because I want the region where the y's are greater than or equal to this line, which is the red one. So I want y's above it. So I would have this pink region. And now I want y's less than or equal to this other line, which is the black one. Now the reason I've done that is that creates this gray overlap region, and it creates it very easily. Now they're talking about using test points to figure it out, and while that would work, you could just like test to see if it makes an equation true. I think what I'm doing here is much easier. Now they want to know if 10 small and 40 large is in her solution region. So if this would be an option for her to display. Well, if you look here, 10 smalls were my x, right? Yeah, smalls are my x. So we're looking for the point, hold on, I forgot what it was. Looking for the point 10, 20. Well, here's 10 and here's 20. So yes, right? Oh no, I'm sorry, it's not in the read. Okay, so here's 10 and here's 20. So it's just true for one of the points. It's not true for both. If it's going to be a solution to the system, it would need to be in this gray area. So the first one is not. Now they do it again with 20 small and 10 large. Well, that's 20 small and 10 large. That is in the solution region. And so this is a possibility. This would make both of her equations true. It would make it so that she's displaying enough photos and that it's cheap enough in price. So the second point is in the region, and so that is true. It is a possibility. Now, if you didn't have the picture, didn't want to, like your graph wasn't good enough or whatever, you could just plug these points into both equations, and it has to make both of them true to be a solution to the system. Okay, so let's try again. Now, I don't have the graph up here. I should have copied and pasted one. Okay, so this is number of microwaves and number of printers. Okay. So this one's a little different. So we've got, it's 30 pounds for every microwave, and it's 20 pounds for every printer. And we need the maximum weight. So we can go up to 160, but we can't go any farther. And now next we have 2 cubic feet of volume and 3 cubic feet for the printer. And it needs a maximum volume of 15, so we can't go any higher than 15. Okay, now if I was going to graph these, I'm going to make, that's a 20. So I've got to divide both sides by 20, the entire side over there. So I'm going to get y. Now I'm sending him over here, and I'm going to just go ahead and reduce it, but it's like negative 30 over 20 is going to turn down to negative 3 over 2, and 20 into 160 is going to be 80. Okay, now that's one of them. I would graph this one. Now let's do this one as well. So here's equation number 1. Now let's start working on the second one. So I've got 3y is less than or equal to negative 2x plus 15. Now we're going to divide both sides by 3. Now I'm giving the 3 to both of them. So 3 into 15 is 5. Okay, now it's going to be very difficult to get this to work, to graph them without proper paper, but I'll try it. Okay, now I did these by 5s along the y's, and I don't think it's going to work. Let's see. All right, let's try this and see how it turns out. Okay, so I'm graphing these two lines. This has a y-intercept of 80, so I tried to make that up here. So I was going by 5s was my scale. So this one I tried to make 80. So now we're going down. This is going to be really hard. Down 3 over 2. Down 3 over 2 would be something like this. Now I'm going to graph it as if it were an equal line. Because it had an equal sign in there, I get a filled in line. And we want the y's to be less than. So we are happy with anything like that. Okay, so now I'm doing this one that has a y-intercept of 5. Now I want to go down 2 over 3. Down 2 over 3. So we're going to get this real steep line. It has an equal sign involved, and so I would do that. Okay, so they're going to intersect over here somewhere, and I'm going to get this shaded region. So this isn't going to work very well with this kind of scale, but let's test now to see if which of these hold this true. So this is my x and this is my y. So I'm going to test the point 4, 2. Now I'm going to just do it into the equations and see if they make true statements. We can use any version of the equation, but let's go back to these. It needs to be true in both. Okay, so I'm putting in 4, so I get 30 times 4 plus 20 times 2 needs to be less than or equal to 160. So what do I get? I get 120 plus 40. Okay, that's going to be true. You see, that's 160, and it's going to be less than or equal to, just barely. It's equal to 160, but it works. Okay, now let's try the other one. Well, this is my x, and this is my y. So I've got 30 times 7 plus 20 times 3. Oh, I'm sorry. I've jumped ahead. No, I have to test this in both. So I tested this 4, 2 in the first equation. I should be testing it in the second. So 2 times 4 plus 3 times 2 has to be less than or equal to 15. That gets me 8. That gets me 6. So I've got 14 is less than or equal to 15. So this is true. This is a solution to the system. Okay, so this is really daunting and time consuming here, so I am run out of space. I'm not going to try another one. But so I would just put 7 and 3 into these equations again. I can actually see right away it's not going to work because 7 times 30 is going to get me 210, so I'm already too high, so I can actually stop the process. That point could not be in the solution because it doesn't make the first system true, first equation in the system. Okay, I don't know why I have on this twice on here. But let's set this up. I think I'm probably going to give up on graphing it. I'll set them into the graphing the graphing form. Let's see. Okay, so we've got, I'm going to have X's be my answer sheets, and Y is going to be my pencils. So it's number of answer sheets and number of pencils. So she wants the answer sheets is at least 5 more than the number of pencils. Okay, so she wants this to be at least 5 more. Give me just 1 second. Sorry, I had to pause it there and I lost my progress. So what did I say here? Number of answer sheets. And Y is number of pencils. Okay, so we need to make 2 equations. So we're building in this first one here. The number of answer sheets is at least, okay, so we're happy with 5 or greater than, so we're at least would be greater than or equal to 5 more than the number of pencils. So there's one equation. And then here's the second. The pencils cost, well, 2y. And the answers are 1 per answer sheet. And her total cost, so this is cost now, 2 times y and 1 times x. For a maximum cost, we cannot be any more than $400. Now we have our 2 systems, and then we would graph them. I think I'm going to skip graphing them, but I would set them up. So I just bad luck on how I chose mine, but I'm going to send 5 to the other side. Okay, now I don't want to do it this way. I'm going to reverse everything. So everything's been flipped around. So at y is less than or equal to x minus 5. Okay, now let's try this one, and I'd have 2y divide both sides by 2. Now I'm giving this 2 to both of them, so there's like a 1 there. I'm going to make that negative 1/2 x, and I'm going to make this 2 into 400 is going to make 200. So once again, I'm going to have a scale issue if I tried to graph this. But so this would be, I would graph each of these as if they were lines. I would want the regions below both of them, and somewhere they would run over top of each other. Now let's just try one of these here. I don't know why I have this on here twice. So she wants is 100 pencils and 100 answer sheets in the region. If you had a great graph and it was done to scale, you could just see if you were in the overlap region. But we're not in that position, so we're going to put them in and see if it makes this true. So I'm putting them into these original 2 equations. So answer sheets was x, so I'm putting 100 greater than or equal to 5 plus 100. Well, you can already see this has broken the system. It needs to be true in both, and I already have 105 on the right, so 100 is not greater than or equal to 105, so that's not true. So I'm going to go ahead, so this one is not true. Let's go ahead and just take a quick look at this. If I had 150 answer sheets greater than or equal to 5 plus 150, yeah, it's not true here either. So 150 answer sheets would be there, greater than or equal to 5 plus y. Yeah, so that one doesn't turn to be true either. So I don't know what happened here, but so at least in this case, as long as I have it set up right, neither of those would be a solution. Okay, so I think we've got the same thing, and hopefully they've got a nice pretty graph for us. So let's see what they've got here. All right, so we have our dictionary is here. We've got the number of hamburgers and the number of cookies. And what do we got? Okay, so we have an equation where it's 250 calories per hamburger, 160 calories per cookie, and Omar needs to eat at least 800 calories. So here's one equation. And now we are going to do it based on the cost. Hamburgers are $1.40 each. It's 50 cents each for the cookies, and he doesn't want to spend any more than five. Okay, so here's our system. And again, graphing these with these word problems is making for some difficult scales, but they've done it here for us. Now, we know if we had set this up, solve this for, I would have used x and y, and we'd used a normal scale. Then we could just do our normal greater than or less than to find this. But if not, what you could have done is just tested below, any point below, to see if that would hold it true, and then you would shade, or any point above. In this case, they chose 0, 0 to do a test point. But so any test point, so they chose 0, 0. So let's show that this makes this true. Okay, so that gets you 0 is greater than or equal to 800. So that is not true. So this one, I'm assuming, is the black line. Yeah. No, it's the red line. Okay, so we found that the region below did not work, so it must be the region above. So they shaded that red. Yeah, what they're doing is clever. They chose the same point each time. So if you put this in the black equation here, and you use 0, 0 again, you're going to find that it is true. So then that region the blue is true, less than that line. Okay, well, we have this overlap region right here. And so we can check the two solutions to see if they're true. So, yeah, this isn't right. We're checking 3, 2. So 3 hamburgers and 2 cookies. Well, let's see. 3 hamburgers and 2 cookies. Yes, that's in the region. So that would be yes. And then they're testing 2 hamburgers and 4 cookies. 2 hamburgers, 4 cookies. No, that would not be. It's in one region, but it would have to be in both. Okay, I'm going to set up just one more of these because of the trouble I'm having with the scale. So, what's he doing? So he's got donuts and energy drinks. All right, now, sorry, my phone rang. Got the number of donuts and the number of energy drinks. All right, so I'm going to start with the cost, but you could go either way. It's 75 cents for every donut. It's $2 for the energy drinks, and he only has $25 to spend, so we can't go over that, so we have to be less than or equal to 25. The donuts have 360 calories each. The energy drinks have 110. And he's got to get at least 1,000 calories, so he's got to be greater than or equal to 1,000. Okay, so I'm using x and y, which would make it easier to solve. But so we would graph these and then so if I'm solving for y, I'd be less than this line. Yeah, this one, if you can look ahead, you swing this to the other side, you're going to be drawing below the line because it's y's. You want the y's less than. And here you're going to want the y's above it, so you'd be going above the line. But their test point idea is pretty clever too. You could do that. All right, let me just test one more of these and see if it's true. I'm going to put in 8 donuts and 4 energy drinks just into these equations and see if it holds true. So I'm doing this. Now I'm just going to go ahead and put it into the other one as well. I don't know if we'll need it, but now that point has been put into both equations. If it makes the truth, then we are going to be happy. We'll have a solution to the region. Okay, so 0.75 times 8 gets me 6 plus 8. This is going to be 14. Yes, that is less than or equal to 25. So this does make this one true. Now, it's got to be true in both, so let's try this one. I've got 360 times 8. I get 2880. And now this is 440. Now you can see here this is going to be greater than 1,000 because it's already greater than 1,000. So this is true in both. And so yes, he could buy 8 donuts and 4 energy drinks and be in the acceptable region. All right, I'm sure if we tested this, I have a feeling it's going to be no. But that's how it works. And again, I'm sorry without this being to scale, that isn't super helpful. But if you want to remember how to graph them, just go back to the previous lesson. We covered all that there. And in that one, I discussed how you can easily tell whether you want the y's above the line or below and how you create that overlap region.